Hey, here we are. Happy
How's it
Thursday
going?
evening to everybody. Welcome to the show, Nick.
Thank you. Good to be here.
Yeah, it's been a while since we've done one of these live streams. Decided to do one here. Nick and I had talked a while back about getting on here and talking about leak detection. I forget where we were probably talking at AHR, and you started talking about a bunch of stuff with leak detection, and I went, "Wow, we've got to share that." So here we are.
Awesome. Yeah, glad to be here.
All right. So tell us a little bit about yourself. Nick Stojkovski from Inficon. What do you do at Inficon, Nick?
So I'm the global applications manager for Inficon Service Tools. So Service Tools, obviously, for everybody on this show, we are the group within Inficon that makes all of the tools for the HVAC and refrigeration market. Specifically, what I do is I go out, I train, I work on new products and some new product development, do a lot of voice of customer. So really kind of liaison, I would say our group is for a little bit of everybody within our Service Tools group. But yeah, podcasts and live streams and trying to get the word out is part of what I do. So
Gotcha. All right. So you Service Tools group. Inficon is a lot bigger than just the HVAC tools that we know them for. What else do they do? Because my understanding is you bring a lot of technology in from some of your other divisions into the HVAC world, right?
yeah, absolutely. So Service Tools is, I would say, well, up until now, one of the smaller groups or smallest groups within Inficon. Where we actually are involved in the semiconductor industry pretty heavily with like quartz crystal controllers, or we're heavy into vacuum control, and then also, especially for our tools and our leak detectors, we're involved in production level leak detection equipment. So the tools that you'll see, or the benchtop leak detectors that you'll see at the factories that big OEMs use, we're able to share technology and steal from some of those high-end units and transfer that to our world, I would say, in Service Tools to really make some killer products. So
bringing that into some handheld stuff that can go out into the field a little bit.
Yeah, and having the same minds, or being able to tap into some of those minds that are working on some of those really high-end equipment, vacuum control, really having a deep understanding, physicists working in vacuum control, going to them and saying, hey, this is what our customer base uses, or what our customers see on the day-to-day. Is there any correlation, or is there anything that we can really do to change or make better? Having those people and those folks work on our stuff has been awesome.
Very cool. Yeah, that's the scientific world and the production world is often very different. And there's some crossover, but they do things one way, and oftentimes we work in a little bit, I'll say, less controlled environment
yeah.
than what they get. So it's interesting to see that being moved back and forth between those two environments like that. So it's
and it's funny when you write specs compared to some of the tools that they're used to, or some of the equipment they're used to. It's very, again, what temperature does it have to work in? And we're like, well, I don't know, 30 and snowy, or it could be 100 degrees and crazy humidity. So
yeah,
it's fun. It's fun to see the reaction.
Yeah, they look at you and go, "You want to do what?"
Yeah, definitely.
So a little bit wider range than probably something on a bench top or on a production line for sure.
Right,
so,
right.
Well, that's cool. All right. So let's dive in here. let's dive into some of the stuff we were talking about. And I put down a laundry list, obviously, that we published out there, and we'll try to get through some of that, or actually all of it. If you guys have questions tonight, we are live here. Throw questions in the comments. We'll see them. We'll try to get them answered for you as we're going through things. I think Nick might pull up some slides later that have some diagrams and drawings and things, because we all like pictures and drawings and circles and arrows, right?
Mm-hmm.
Absolutely. So let's talk about, I'll say levels. Like, what kind of levels are we looking at when we're looking for a leak in, let's say, a residential application and or maybe like a commercial application, or a grocery store application or something like that? When we're talking about levels of refrigerants, what are we looking at?
I think so. When we're looking at different levels, it obviously changes. It changes off of a couple different instances, and we'll get into this a little bit. But when we correlate this to a leak detector, our leak detectors are capable of really, really low levels, right? So when we talk about 1 gram per year in terms of sensitivity on a leak detector, the chances of you looking for something like that in the field is going to be probably small, right? We're really looking for something that might be 100, right? If in a residential application where it's a, it's a low pressure system, it really just depends, on the environment, but anywhere from 100 grams per year, right? 50 grams per year, or if I've got a really high pressure system somewhere, it could end up being, 10,000 grams per year. And we would call that an absolute geyser of a leak. But the important part, I would say, of all of those scenarios is it's really important to understand your equipment and how they perform in each one of those scenarios. Each one of those scenarios are going to provide their own set of challenges. So when I say looking for the small leaks isn't always the most difficult part of leak detection. Looking for a small leak in a big background is pretty difficult. Looking for a large leak in a big background could be difficult. And I'll relate that to, like, let's say CO2, right? So all of those scenarios that we talk about and the levels, just because we have a bigger leak doesn't necessarily mean it's easier to find. And just because I've got the most sensitive leak detector on the market, doesn't mean that it's automatically going to mean that I am able to go find these small leaks. There's definitely, I would say, a systematic approach to being good at leak checking. It's almost a little bit of an art form, if you will. And so again, understanding the different technologies and how they work in each one of those environments is definitely going to help.
Gotcha. And I just want to relate this to our listeners out there, because a lot of us are US based. We deal in ounces. 100 grams per year is about a 3.5 ounce leak per year. So, that's still a pretty small leak in a lot of systems, unless you've got a really small, critically charged system. So you're still talking about a pretty small leak there.
Right. And now, even still, we're getting into levels of concentration, right? We've got more capable leak detectors that a lot of people don't even know about those type of ratings. When they think about a leak detector, they really just correlate it to what it can see in terms of a ppm level. Now that we display that level, right? And they'll say, "Ooh, I can see 1 ppm." Well, even understanding the concentration difference versus what a leak rate is can also help you understand how this leak detector is performing. I mean, and we'll get into it, I'm sure, later, but the newer one we've come out with, just going from 1 ppm, now we can see, a tenth of a ppm. So it's, again, how do we utilize that the best way, right? Not just going in and saying, okay, it's the most sensitive, it's automatically going to make me better. How do you utilize the information?
Yeah, and that's something that it took me a while to wrap my head around this, because we talk about this in grams per year as a leak rate, and that's a long period of time to lose a pretty small amount of refrigerant. But then we measure that in a parts per million, which is a concentration in the air. But depending on how close, if we get right on top of that leak, it could be thousands of parts per million if that leak is shooting up directly into the tip of the leak detector, versus if we're, a couple inches away from it, we could be at that 1 part per million concentration, but you still have the same leak rate coming out of the
Absolutely.
hole.
And here's the other, to add to that, right? Another scenario is, how long has that leak been there? So if I have that same leak rate and I walk into a room that has, let's say, 10,000 ppm or 5,000 ppm, the only thing that has changed, right, is how long that leak has been in that room and what has the air movement been in that room. So if I walk in and I automatically see this big 5,000 ppm background, well, then I may look for something that I think correlates to a big background, when really it could have just been how long that leak has been sitting there. If we want to tie this back into like a real life scenario, it would be a closed, case, right? A reach in where cooler, where a leak's been there for a while. Nobody's been there. Let's say over the course of the night, I get there in the morning, I stick my leak detector in the door and it goes nuts, right? I'm automatically expecting that I'm going to find this absolute geyser, like we say, of a leak. But I have a little bit of a difficult time finding it. Well, it could be because my assumption is that it was a huge leak. So again, using the methods we'll talk about may help mitigate some of that.
Yeah, and that 5,000 parts per million background becomes your new zero level, and now you're looking for 5,010 or 5,020 parts per million, but you're zeroing that out and saying, hey, here now I've got to start looking above this for the source of the leak.
Yeah, absolutely. And understanding that the leak detector has what you just said, that automatic zero, which most leak detectors will have this. A lot of times when people ask, they say, well, it went off and it seems to just go away. Well, it didn't go away. What happens is that leak detector, like you just said, it zeroed to the background. And what we're trying to do is help you navigate your way to the next highest concentration. So that way you're not just going off. Let's say you don't have a screen on it, or you don't have any sort of numeric display or PPM. It's the only way, or one of the only ways that we can get you closer to that leak effectively, or trying to be efficient with leak searching. You have to try and reduce the background, so that way you can really, let's say, get a visible sight of that refrigerant cloud, but that's almost what you're trying to do. And again, the closer you get to that leak, like you just said, when you're inches away, it seems like it's a massive amount of ppm. Well, again, you're using that zero to inch towards that leak.
Yeah. And I think that can be confusing for a lot of technicians the first time they run across an auto zero and it happens. And then all of a sudden they're like, I got this really high level, and boom, it's zero again. I'm like, wait a minute, what just happened? And that confused me the first time I ran across it. And I've talked to a lot of other people that I think have had similar instances. So,
yeah.
Well, that's good. Let's go ahead. Sorry.
Well, I was just going to say, I get that a lot too. And understanding the modes in the leak detectors, right? That's not the only mode. A lot of times you may have like a manual zero, right? And then again, you have for us, it's the cloud hunting mode. But again, there's a few different ways to really navigate that cloud of refrigerant.
Yeah. Yeah. Well, let's talk about that. Let's get into some best practices with navigating the cloud, whether it's a big cloud or a little cloud of refrigerant, if it's localized. And let's also, I want to talk about atmospheres with moving air in them, because that's a really hard one, especially when we're working outside.
Yeah.
If there's a little bit of a breeze. How do you navigate that?
So, let's start with the best practices, right? And the best thing to do is always make sure the leak detector is running right. One of the better ways to do that is to get first, let's check our filter to make sure that that's not clogged. Make sure the battery's charged. Sometimes, depending on the leak detector, it really depends on how much, let's call it juice you have in the batteries. Because some of the technologies rely on the ability to heat that sensor up to a certain temperature to create the reaction it needs. There's a couple different connections that we have. a couple different reactions that we have. But in order to, to get that optimal performance, it's rated at a certain level. So filter, battery being charged, and then the next thing is to actually test the leak detector. And I don't mean test it by putting it up to a tank of gas. When I crack that tank of gas, all I'm doing is saying, I've used this analogy before, but it's saying that I have a heartbeat. It's not really telling me how well my heart is beating. And what I mean by that is some sensors will degrade over time or with exposure to refrigerant, like a heated diode or some other reaction sensors. When I expose it to a large amount of gas, I'm not testing the leak detector to the limits that it was made or designed to perform at. So let's say I am looking for that small refrigerant leak. When I have said that I've tested it, and it's if I crack a tank, it could be 100,000 ppm, right, leak, or it could be, who knows, tens of thousands of grams per year. I have no idea, right? But what people do sell, I mean, we have one, is a calibrated leak standard. Ours will leak at 5 grams per year. And what's nice about that is, that you're going to go off to those low levels of leaks that you would expect your leak detector to perform at. So it's a very consistent method. Nothing's worse than going through an entire store and not knowing if this leak detector was working as you thought it was, right? Or let's say even the residential folks. It's like if you get done with a job, you thought it was good, and then you get called back 2 weeks later, I'm out of gas. It's not a fun scenario to be in ever. And so that's one really easy way to make sure that the leak detector is working. The second part would be is making sure that you start this outside in fresh air. Giving it a good zero background is always a good idea, not because it won't find, again, the next highest level of leak or ppm or concentration, but because it's really going to help you understand what you're walking into. If let's talk about it like a grocery store, if I start it up outside and I walk into the let's say I'm the first one there in the morning and the door's open, right, at the front of the store, and my leak detector is on, and all of a sudden I get a large 15 ppm background or a hit on gas right away, and then it may go away, dissipate as that door opened. Well, you can count on that you're probably going to be looking for a leak, a pretty big leak in that store, because you actually have a background in the entire store itself. Same thing when you're walking, sticking it in near an evaporator, a residential, something like that. You're able to kind of gauge based off of some sort of background that you have that you should be looking for a leak. So again, keeping it on, and then depending on what situation I'm in, right? If I'm again, I'm going to talk grocery store. If I'm walking to the mechanical room, keep it on the entire time, making sure that it's warmed up to the fullest, right? Like for us, we have a 90-second warm up on the Stratus, but really, the longer you leave that on up to a certain point, a couple minutes past that, that's when you really get the full range of the sensor or the full sensitivity. Heated diodes, they have to warm up, right? That's why you'll get a longer warm-up time, is because they need to hit that certain temperature. And then, keeping it down, the leak detector down close to the floor as you're walking through certain scenarios is going to help you pick up accidental leaks. Understanding that when we get to air movement, right? Just because I'm close to the leak doesn't always necessarily mean that I am going to pick up that leak, right? So if I've got fans or dampers open or anything like that in the environment that I'm checking, it's good to understand where that air is flowing, because you're always going to need to have the gas in front of that sensor or probe tip for any leak detector to pick it up, right? If it doesn't ever make it to that sensor, it's not going to react, and it's not going to alert you that there's a leak. So those are kind of some of the tricks, I would say, some of the very basic tricks that we have to just keep ourselves consistent. And I would say that's the name of the game with leak detection, is to make sure you are consistent.
Gotcha. Yeah, I mean, if you got a leak shooting out the side of a pipe, right? It's coming out the side of that pipe, and the wind is blowing across it this way, but your detector's up here. The detector's not going to see anything until it gets past the leak. So you may have to get real close and travel back or something like that.
We had a scenario where we were on a rooftop of a large grocery chain, and we were actually doing some testing of a newer leak detector that we had. And so we were checking some level gauges for the receivers, and it was on a rooftop. All of these were on the rooftop. So in the past, they haven't really been able to pick them up because, one, they were using the Stratus incorrectly. But two, again, it was just because the way that it was actually coming off the coast, the way that the wind was blowing was never really right in the path of the probe tip. So the gas never really made it to the leak detector. And it was only, actually, credit to the technician that was there. He's the one that kind of was like, whoa, wait a minute. But when I actually had the probe tip kind of downstream of where the leak was, the leak detector started going off, and I started thinking, oh no, there might be something wrong with this leak detector. It was actually like 10 or 15 feet away from this leak, and it started going off on the rooftop. And I'm like, oh no. I looked at my boss and I said, I think something's wrong with this thing. And the tech grabbed it out of my hands. And he's like, I don't think so. He goes, give me that. And he shoved it up to the side of the louvers of where the cabinet was on the rooftop, and it went nuts. And it was actually a leak inside of that cabinet. And it was because the wind blew across and right in front of where I was standing. We were able to pick that up, and he actually brought it back to to inside that cabinet. So again, he had the knowledge to say, and kind of the wherewithal to say, ooh, there definitely could be, look where we're standing. It's way over here. Let's check that. Let's check that cabinet, see if there's a leak in there. Sure enough, there was a pretty good leak in there.
Very nice. Yeah, I mean, that was a good find. Sometimes, what's that saying? Sometimes it's better to be lucky than good.
Yeah, absolutely.
Yeah, that's something that's really challenged me a couple times is leak detecting outdoors, especially when you get some wind moving across the area that you're trying to work in. So let's talk about an approach to leak detecting, because that's something, to me, that's part of the approach, part of that, I guess, art form, as you said earlier. When you're walking up, you're thinking, okay, how am I going to approach this? And what's some of the thought process that goes through your head if you're walking up to approach some different leak scenarios and thinking about what you're going to do?
So yeah, let's go over some scenarios, right? If like I said, grocery store, if I've got a positive pressure environment, and I know that I'm sitting on the other side of a door and I see a few ppm, it's always good to understand where that could potentially be coming from. A lot of the times I've actually been outside of a walk-in cooler, and I've been able to trace myself or use the leak detector to actually guide myself to inside the walk-ins, because really it's where the air is flowing. When you're walking into a mechanical room, a lot of the times there's a lot of cooling going on. There's a lot of wind going on. If you can, it's always good to eliminate that craziness, right? With all that wind in the background, and allow the background of refrigerant to start to build. So shutting down any sort of fans, dampers. We were in a grocery store where it had a lot of the point leak detection systems, an aspirated system, and they had a lot of little points. I would say a lot of hoses going everywhere where it would lead back into a sensor. The background on that leak detector showed that there was nothing in the background. There were no leaks. It was only until we shut down the fans and really shut down the air movement, where all of a sudden, within a matter of 10 or 15 minutes, you saw the background start to build, right? And it didn't build a little bit. It actually went to 10, 15, 20 ppm pretty quick, which is, for a larger area, is a pretty big deal. So understand, what could be taking the we're going to call it the sample away, or the refrigerant away, blowing it around, causing it to diffuse in the air or leave the room entirely. And then other tricks is, that you can do is always go and try and leak check at the most optimal times, right? That's going to be the highest pressures in the systems, because if I have let's say I have a leak let's say I have a 1 millimeter hole. Well, it's really, the hole isn't going to change, but if the pressure in that system changes, it's going to look like a bigger leak, right? So if I can shut down, the compressor, and I can get that suction pressure up, right, that's going to give me a better chance of finding that leak. If I know I've gone into hot gas defrost, that's going to give me, sometimes we have instances where leaks may come and go, right? And it's because those let's say the instances, or the pressures or environment of where that leak was in has been changing, right? It'll change and come back. And again, it's because pressures may be going up or coming down, or maybe it's a fan that keeps turning on at a certain point of the day to start cooling a certain piece of equipment. So again, understanding the environment around you is really going to make a difference.
Gotcha. And that's all things you got to think about while we're going in to start doing this. Kind of have a plan of attack, because I've walked into those leak detection scenarios before myself, and early on, I just walk in and start waving a wand around, right? No plan of attack.
Mm-hmm.
I've found that it helps to develop a plan of attack.
Well, and the other part too is, like you just said, waving the wand around, going, going slow. Every leak detector is going to be a little different, but take your time. The slower you go, the better off, or the more you're increasing your chances of finding that leak, because you're giving the leak detector a chance to actually breathe that air in. So if I'm just kind of waving this thing around and kind of giving it a blessing and going away, the chances of me finding a leak are going to be pretty slim. So taking your time definitely will help.
Yeah. All right. Well, that's some good thoughts there on different ways to approach this. You've touched on some different technologies in here a little bit. What are the main technologies that we're using in leak detection? Now, I put this as leak detection because I kind of thought, hey, we also use flammable refrigerants now flammable gases for refrigerants. So this kind of crosses over into doing leak detection in places like even natural gas and propane systems as well.
Mm-hmm.
So it's a similar philosophy. Anytime we go in, because we're detecting gas here. So this is really focused on gas leak detection.
So, if you want to bring some of these slides up, I can actually talk about some of these sensors.
Yeah, let's talk about some different technologies here, and then we've got a really good question here that's going to tee up another topic we wanted to talk about.
So one of the most common things that I get is people asking about ultrasonic leak detection. And so this isn't actually reacting with any sort of sensor itself. It's actually listening to the leak. We have one that will actually listen to that certain frequency that the leak detector makes. It's called a whisper. And the nice part about this is, when you don't have the chemical that you need for that sensor to react the way you need it to, and to make the alarm, this doesn't really, ultrasonic really doesn't there isn't really that boundary with ultrasonic. So anything in pressure or vacuum is going to make that sound.
Yeah, it's agnostic to what is going in or coming out of that pipe. It could be air coming through there, right?
Yeah, exactly. Now the only there's some limitations, and the way that we like to say this is it's a good addition to the toolbox, or another tool in the arsenal, but it really, for certain and special instances, it's really good at what it does. But you really got to learn technology, and you have to really be comfortable with the tool. It takes some time to really learn the tools, because there are chances that that's not the only instance where that tool is going to hear that frequency, right? For instance, if let's say you're checking a TXV of some sort and you've got some gas coming through it, there's potential for it to resonate at that frequency. So those are just things to be aware of. It's always good to have something like this in the toolbox. But that's really how this technology works.
How realistically, how small of a leak can you go down to with an ultrasonic technology?
So the actual range, so it's not going to find your 1 gram per year leaks, right? I don't remember off the top of my head what the ultimate sensitivity on it was, but it's going to be for rather big leaks. When you're really looking for the let's say 10 gram per year, quarter ounce per year, that's not something that you're going to want to rely on an ultrasonic to find. It's just going to be a little challenging in that environment.
Gotcha.
Corona suppression is another one that you used to see quite a bit. And so what this technology really does is it ionizes the air in the sensor, and it creates a corona. And then anything that kind of disrupts that corona, really like we're saying here, the refrigerant absorbs the electron, reducing that current in that corona. That's how, as we're suppressing the corona inside that sensor, that's what changes the signal, and that's what gives you the alarm. The problem with or I wouldn't say the problem, but some of the hardship with a trying to use this is it really is cross sensitive. This technology could be a little more cross sensitive than some of the more specific and more modern tools or sensors that we use today.
Yeah, and that's a challenge with a lot of sensors that we have in the HVAC industry, is they become cross sensitive to other gases because they're similar enough.
Right. Yeah, exactly. And when they're not specifics is when we get into trouble. We start wasting time is what it really comes down to, because it just starts alarming everywhere, and it takes a lot longer to find where that leak is actually coming from. Here's a very common one that we see in some of our tools, a lot of other tools out there, is a metal oxide sensor. So, and what happens is this really is absorbing the oxygen from the air, and then it uses the refrigerant to react with that oxygen, and that's how we change the resistance on the sensor, and that's how we create the alarm. Again, it's really good because these actually have a pretty long lifetime. The downfall on them is going to be the sensitivity, and the cross sensitivity again is really going to be where these may fall a little short. But hasn't been a terrible technology by any means. And it allows us to react to not only like refrigerant, but also methane, right? And gases like that. So kind of a multi-use sensor. And then here's one that really shines, especially for the residential folks. This seems to be more of a common, I would say a collective, feedback that I get from a lot of our technicians would be that they really like the heated diode, because it really is a selective sensor specifically to refrigerants. And the reason being is because it's actually ionizing the chlorine and the fluorine. So what happens is it'll heat up to 1400 degrees Fahrenheit, which is pretty hot. But what it's doing is it's almost breaking apart the chlorine and the fluorine, ionizing it, and then it creates that reaction that way where that's how we change the voltage across the sensor or change the signal. So very specific to refrigerants, right? Because they're, that's what those refrigerants typically are made of. So anything else that's out there is it doesn't have the same sort of cross sensitivities to them. And it makes it a little easier to use, I would say, in the field. The problem with, I would say, a heated diode, and this is where we get into the consistency talk, is it does degrade over time. So these reaction sensors tend to lose their sensitivity as you use them. The heated diode, same thing. It really, unless you're again, this is where it's important to use our tech check or a leak standard of some sort that is calibrated, more of a calibrated leak, because it's just like a razor blade. The more you use it, the duller it gets. And if I'm halfway through this life and I think that I'm performing the same as I was when I first got it, and I didn't realize it actually degrades, it could pose some challenges and it could cause me to miss some leaks. So again, just be aware of that as part of this technology.
Well, and if somebody say, they're testing this, we're going to say, like you talked about earlier, just by cracking a jug of refrigerant on the back of the truck and shoving that sensor, that nozzle right into the cloud, the high concentration cloud of gas, you're actually not checking it. You're weakening the sensor every time you do that.
Absolutely. Yeah, exactly. You're poisoning that sensor, we like to say, when you do that, because you're just kind of overdosing the sensor with medicine in a way, and making it numb to the background. So again, sometimes just a little leak goes a long way, a little medicine goes a long way, and that's really the right way to check the any leak detectors, to use a calibrated leak
source. Yeah. So
Yep.
I mean, you guys keep doing that. We sell leak sensors, so just keep coming back. I mean, if you want to throw those in big clouds of refrigerant, just call us up. We'll sell you new leak sensors all day long. Replacement sensors, we can do that.
Absolutely.
But if you don't want to buy as many replacement sensors, then get yourself a little calibrated leak check bottle and
Right.
use that.
Right. And so this is what ours looks like. The other part of, I would say, the heated diode is they are very sensitive. So 1/4 ounce per year. And it's only improving. We have one coming out very shortly here that's going to be even more sensitive than that, and even more longevity or lifetime with it. So the technology is only being improved over time. And again, it's a good entry level, more cost-effective solution, I would say, for somebody who's not looking to spend a ton on a leak detector, may not use it all the time. But to have a good, reliable leak detector, having that true heated diode. And I would say, I would caution you, there's definitely some misunderstanding of what a true heated diode is versus, a tin oxide sensor. Some people or some companies will say that there is a tin oxide, and it's just good to make sure you understand what you're getting. If you think you're getting it, if you want a tin oxide, make sure that's the technology. But a true heated diode has specific properties that's going to perform the way that you would expect it to.
So, and this brings up a question to me, because I think a lot of us have seen these sensors be cross-sensitive to things like certain leak bubbles and things like that. So you spray that leak bubble on there, and then you go back in and try to detect something, and you're just getting alarms all over the place. And that's going to be probably, I'm going to guess, something off gassing out of that leak solution. Can you speak to what that is? And
a lot of times some of these bubbles are ammonia based, and so some of these cleaners also, I would say, are ammonia based. So it depends on what's in them. Some of them have alcohol, some of them don't. Those chemicals are actually like ammonia. I mean, it's an actual refrigerant, right? So it's supposed and designed to work with ammonia. When the other part that ends up happening, if I stick it on a bubble pops on the sensor itself, it actually might change the flow or get into that sensor. So that's the other part, is if you change the flow of some of these sensors that rely on the heat element and the airflow going across them, that could change the voltage or resistant value across the sensor. So that way, it thinks that there's an actual leak there, or you're actually making it react, or thinking that there's gas there because you've changed the airflow across that sensor. So just something to kind of keep in mind. And then, here's, I would say, this would be the gold standard, I would say, of leak detection now, not only in our world, in the surface tools world, but this is where, even in the production realm, this is where they are now, is using infrared. And the reason why infrared is so good is because it's very specific to refrigerant gases, or whatever gas, let's say CO2, or even hydrocarbons. You're able to filter the light and specific wavelengths of that sensor to target specific gases. The other part is this does not degrade over time. There's no actual chemical reaction happening with these. So if you think about, it's almost like shining a flashlight on a wall. And if I use my body as a refrigerant molecule, if I walk in front of that flashlight, I'm going to eliminate that light there. So if I don't see as much light at one point, that's how I'm actually telling you that there's refrigerant present. So same thing. You've got a infrared emitter and an infrared detector, and the gas flows through that body of the sensor, and as that light is being absorbed, it's going to change the value that detector sees, and so that's how we actually will tell you if there's refrigerant present. It's going to work. It's going to be as sensitive, again, as the day you buy that tool, or the day that you start using that sensor, to the day that it actually tells you need to replace that sensor. There's no degradation. There's no in between. It's going to be 1 gram per year the entire time until it's time to change. And that's been an awesome property, I would say, of these infrared sensors. The other part is we're not as sensitive to temperature changes and humidity. Those are some points that really are a negative, I would say, to some of the reaction type sensors, where this is a very stable sensor, and it doesn't react to some of those instances.
Okay. We got a great question here about the IR sensors. I'm going to pop it up on the screen from RR Hale. Are any cleaning needs for IR optical instruments?
So no, actually, really the only thing you need to make sure you do is to use the filter at the tip of ours is at the tip of the instrument.
Yeah. As long as you got the filter before.
As long as you have the filter, yeah, you don't need to worry about this. This is actually a sealed sensor. You really don't service the sensor at all. If there's anything wrong with ours, it'll actually tell you that there's an issue. But as far as maintenance wise goes, yeah, you don't need to touch the sensor at all. Just make sure you're using your filters. And that goes for every leak detector, not just for infrared.
Yeah, because I can imagine if you get like some oil or something like that in there on the inside of that tube, should it, if you don't have the filter in and the pump manages to pull a little oil or something in there, that it could maybe coat the inside of that tube, I'm guessing.
Yeah, there's always a chance that you get some particulate in there. The good news is we're actually going to tell you, again, if there's an issue with that sensor. Our tools, especially for us, Stratus, and obviously D-TEK Pro, we're able to really have onboard diagnostics with these tools now. So where before, our older tech mate I'll speak to, or really any older leak detector, it doesn't really tell you if there's an issue, right? The modern technology, we can do that. we can tell you that there's an issue.
Okay. Got another great question here about this. And this kind of goes to all the leak detectors from Austin 419 over on YouTube. How often should the filter be replaced?
I'm going to relate this to a vacuum cleaner. How dirty is your house? Right. If I'm sticking this into really dusty environments, getting it down into drain pans, I'm sticking it in areas like a grocery store that hasn't been touched in 30 years where I'm getting dust bunnies everywhere. It's going to be pretty quick, but usually like if it's in areas where I can see the pipe and there really isn't any dirt, it's tough to say. So it's really based off of use. But the one thing that we can do in our leak detectors is you can just look at it. So that's why I say it's always good to just check your filters before. It's so easy to do. Just look at them, right? Just give a visual inspection. Does it look pretty dirty? Then maybe time to change it, right? But if it's nice and clean, then you're probably good to go. Talking about new diagnostics, our new D-TEK Pro that we're launching, that'll actually tell you when it's time to change it. It's going to tell you high flow or low flow. If you disconnect the hose, it's going to yell at you. And so again, we're getting better, as I would say, as technology goes on, to try and eliminate the uncertainty behind some of this. But always just visually doing an inspection is going to help, maintain any tool you have.
Yeah. I kind of relate it back to how often should you change the air filter in your HVAC system? Well, how often does it get dirty?
Right. Right.
So, but yeah, great question there, Austin. Thanks for asking that. So gold standard IR, we pretty well done with different technologies then?
That's pretty much it. This is the in terms of the lifetime too, I would talk about for infrared, where our older heated diode, the original one we came out with is, around 100 hours of use. This is an outdated slide, but we've tested up to 2,000 hours now. And,
wow.
So where our D-TEK Pro, the new one, you're talking closer to 5,000 hours and in counting. So that's the other part is, they may be a little more expensive up front, but the consistency and the longevity of the sensors is going to make up for some of the replacements that you're going to have to do with and the price point that you buy them at, right? They're a little more expensive, and the cost of entry is a little more expensive with an infrared leak detector, but the benefits, especially if you're doing a lot of leak detection, far outweigh, I would say, the negatives.
Gotcha. Okay. All right. Well, let's get to another one of the questions we've got up here, and we're going to switch gears here, and we're going to talk about trace gases.
Yeah.
So you need slides anymore?
I do not need slides anymore.
All right. We're going to take the slides off. Zach Popovich wants to know thoughts on trace gas or nitrogen plus some refrigerant like 410A to do leak checking instead of just nitrogen. And he's using the Stratus to leak for checks do leak checks, and he's had good luck with that. So, Zach, thanks for the question.
So this is kind of a tricky topic, right? Because if I don't use trace gas, then I can't use my IR. Like, let's say if I don't use some sort of trace gas and I don't have the chemical that a refrigerant leak detector is going to pick up, then I can't detect that leak. If I'm doing pressure decay, it's going to be tough to tell or target where that leak actually came from. Same thing with vacuum decay. So there's two ways to find the leaks there or tell that you have a leak, but to target it, you can use, let's say we talked about the ultrasonic. So if I'm going to just use nitrogen, then that's really one of the only ways that I can do it. The problem with and this is, it's not going to be all the time. But you got to remember, our leak detectors are rated to specific concentrations or 100% concentration of gas at, let's say, for Stratus is 1 gram per year. There's a couple of inconsistencies with that method of checking, because if I'm putting the same amount of tracer gas in 2 different systems, and let's say one system is a small water bottle, and then the bigger system is a giant jug, right? If those volumes of those systems are different, the blend of that tracer gas is going to be different. And when we relate that back to what my leak detectors are actually rated for, it's going to be tough to say I am actually going or have the ability to pick up a specific leak rate. So I may be really sensitive to the small system, but I may not see the bigger system at all. And anywhere in between, like what we talked about earlier, consistency is key in finding leaks and understanding the performance of that leak detector. That's why that 5 gram per year leak is, that leak standard, that calibrated leak is so important. If I don't know that blend that I'm using, which it's really hard to do. I mean, all systems are different, right? All line sets are different. If you're talking VRF, you got pipes going everywhere. It's really tough to do that. And then also the other trick that this may help you, but it depends on which way you're doing it. Are you putting the trace gas first, or are you putting in the nitrogen first? Because if I've done a pressure decay and I've put nitrogen in there and I said, okay, now I'm going to shoot a little bit of trace gas in there of, let's say, 410A, and I've already charged the system, and now I just want to put a little bit of gas. There is no guarantee that that molecule of refrigerant is going to make it to that leak in the time that I'm checking. I don't know the diffusion rate through that pipe, and I don't know if it even makes it there at all. So if I am leaking and I'm only spraying nitrogen and the molecule of refrigerant hasn't quite made it to that hole yet, well, I'm going to miss that leak. So one way, to make sure that you do this is try, if you can get a blended gas in there as much as you can. And then, or you can use something called forming gas. Forming gas is a known blend, 95% nitrogen, 5% hydrogen. There's, like our gas mate will actually pick up the hydrogen that's in there. Infrared doesn't pick up hydrogen. I would say we don't have a sensor for any of those, our infrared tools that'll pick that up yet. So if I use that known blend, well, now I'm not guessing at what those concentration levels are. I can pretty much charge to a same pressure that I typically would, and then I can be a little more consistent when I'm going through and actually checking these for leaks. The second thing that I would always do is I would pull a vacuum before you pressurize with a tracer gas. Why I would do that is because you can actually create a little bit of an air dam. So same concept with charging with refrigerant while the system's pressurized with nitrogen already. We want to make sure that that blended gas or that forming gas makes it to that hole. And if I haven't evacuated that system, there's no way for me to know that the tracer gas made it everywhere in that system. So if I've got a negative pressure in that system, it's pretty easy to know. We did a test in Syracuse where we pressurized a system or a coil, and we had a 10,000 gram leak on one side of the coil. And we did just that. So we had a leak detector on the end of where that leak was, and we waited to see how long it would take with not pulling a vacuum. So first it was pressurized, and then we put the trace gas in it. It was 5 minutes, or around there. And then we did it the same with forming gas without actually pulling a vacuum, and it was around the same level of time. And then we pulled a vacuum and charged the system with the tracer gas, and it was a matter of seconds. So it really makes a big difference in terms of how long it takes to get to that, and really improves the consistency, which is really the key behind any leak checking.
So if you're going to use tracer gas, best practice then, even with a leak in there, is to pull that system down into a negative pressure, because it's going to distribute out faster, and chances are you're going to find leaks. That's a heck of a tip, because I can say I've used tracer gas with mixed results, and now maybe I know why I had some of those mixed results sometimes.
Yeah. If you can do that and then pressurize, the more pressure, the better, right? You're going to increase that leak rate.
Yeah. Now we are getting up on our hour here, but I think we got a little bit more we want to cover. You want to stick around? You got time to stick around tonight?
Oh yeah. Yep.
Okay. So we're going to run a little bit over an hour, folks. This is all going to be recorded, so you can always come back and check it out later if you want to, but it'll be on the LinkedIn, Facebook, and YouTube. So, but I did want to cover that. And that's a really good tip there. I like that. Anything else on using tracer gases?
Not really. I think we've covered most of it. If anybody can think of any questions with it, let us know. But
I'm kind of curious. You were talking about the mixing of gases, and I'm kind of curious if somebody, or if it could be done to mix a little bit nitrogen and a little bit of refrigerant in like a recovery cylinder and throw it in the system. If that would get a better mix, something closer to that forming gas than just pushing one and then the other on top of it into a refrigerant system.
it would be an interesting test for sure. There's nothing that I've done in like at Inficon to test that, or I don't have any test results to really speak to that right now, but it's an interesting concept for sure.
Yeah, it's just something that just popped in my head here as we were sitting talking about that, and I was thinking about it, and it's like, even if you put the refrigerant into the system first and then followed it up with nitrogen, it could possibly push that concentration of refrigerant all the way to the far end of the system.
It could, or if we've got a big enough system, if only a little bit made it to this leg of the system, it could push that refrigerant out before I get there, and then by the time I get there, now all I have is is nitrogen, right? So whether it totally works just like that, I mean, I think there'll be a little bit of blending going, but the reality is just what we're saying is there's so many unknowns, and when there's unknowns, I mean, you're already chasing invisible gas. If I'm not totally sure what this test environment looks like, there's no way for me to be consistent.
Yeah, and that's a big thing to crack open right there, what you just mentioned, because we're chasing around unknowns, and the more unknowns we can eliminate, the more successful we typically are.
Right.
So, all right, cool. Well, let's talk about some maintenance on leak detectors.
Yeah. So,
real quick, we got a question popped in here real quick before we jump into that. Zach asked, where can you get forming gas? And of course, then you're going to need that hydrogen leak detector too to go with that, right?
Right. So a lot of those supply houses where they sell gas, if you ask for that blend under the name forming gas, typically, or sometimes doesn't ring a bell with them, but if you tell them 95% nitrogen, 5% hydrogen, I think that most places will have that. So just ask for that mix.
So you're going to have to look at like a welding supply house or a gas supply house. You're not going to get that from a standard HVAC supply house, probably.
I haven't seen any of the standard HVAC supply houses around us carry them. If somebody knows that for a fact, I'd love to know.
I'm going to say it's probably pretty rare. I would guess.
Yep, that's what I've seen too.
Yeah, and here's another interesting comment from Mr. Hale. Thank you, sir. Because the densities of gases can be different. Most cylinder gas providers actually roll the cylinder. It's an interesting concept. That's there.
Interesting, yeah.
To put it in the cylinder and then roll it around to mix it. It would be an interesting experiment to do with some nitrogen and refrigerant to be able to make your own mix in a cylinder before you put it into the system for leak checking.
Yeah, or if you leave it there for a certain amount of time and see if you get the same result without, mixing it around. Yeah.
Well, cool. All right, so let's talk about maintenance again.
Yeah, so I mean, the good part about leak detectors is they're pretty simple, right? You have a battery, a filter, a sensor. 95% of the time, it's going to be one of those things that is causing the issue. If you're getting something wacky, let's say like a few ppm on your let's say the Stratus, go ahead and change that filter. It's probably something due to airflow. If that doesn't fix it, then go and see, try and change that sensor. If that doesn't fix it, obviously, that's a lithium ion leak detector. So, then you'd give us a call, but I would be willing to put money that most of the time it's going to be one of those two things. And then for like a heated diode or, more the reaction type sensors, especially older leak detectors, make sure that the batteries are fully charged, or make sure you have fresh batteries in them. That's really what it comes down to. And if you have a way, if you ever seen us out there, we do these things called test and tunes at our local, at your local branches, or if you see us at an event or a show or something like that, we'll have like an airflow, a little airflow box, and or a meter, and we actually check the airflow of those leak detectors. So if you have one, and you can check it that way if you really want to, or if you see us around, just ask us and we'll check the airflow for you. That's a really critical part of the leak detector, is making sure we're moving and checking that flow.
Yeah, you might make sure you got enough flow through the gas path, because if it can't get to the sensor, you can't really sense anything.
Absolutely. Yep.
Awesome. That's pretty simple on maintenance. Not a whole lot there. So that takes us into Stratus. I want to cover the Stratus here. You told me a few things about the Stratus that I wasn't really aware of. Didn't understand well enough, I guess, about the Stratus. And it's a very popular leak detector out there. There's a lot of people that use it, a lot of people that like it, especially when it came out, when with that parts per million display, because everybody thinks that's a really great thing. And you looked at me and said, that's not how they're supposed to be used.
Well, and that
blew my mind.
It's only one part of that leak detector, right? I would say 95% of the people never take it out of that cloud hunting mode that displays ppm. It has an automatic 0 or a pinpointing mode.
Let's back up real quick. You said cloud hunting mode. What is cloud hunting mode designed to be used for?
Okay. So cloud hunting mode is designed to show you or give you a visible reference of what the background cloud of refrigerant is. It's measuring the concentration of refrigerant in the background, right? Or displaying, I should say, the concentration level of refrigerant in the background. And really you're using that for a game of hot and cold for the leak. So generally, the closer I am to the leak, the higher that concentration or that ppm that you're going to see is going to be on the screen. And as you start to walk away where that general area of the leak is, you're going to see that number start to decrease. And what a lot of people like to do is they like to use that also for going and checking joints. The problem is, when you change modes on that Stratus, is actually changing things like response time. There's an actual switching valve inside that Stratus that turns on and off depending on what mode you're in. So the right thing to do is when you're walking into a room, I'm going to keep it in cloud hunting mode. Look for a cloud, start to walk myself to where that leak is. And when I have a pretty good idea that it's in this general area, and typically there's only going to be a few spots where this is going to come from, where when I can kind of get it to some area just right in front of me. Well, that's
you find that maximum concentration. That's what you're looking for in that cloud hunting mode, is getting that maximum concentration, right? And then that's when you switch modes.
Right. And it'll actually show you the max concentration. There's a max feature on there that it'll show you and store the highest level you've seen. But once you're there, that's exactly what I'd want you to do, is to try switching it into pinpoint mode. Now, if you've got an absolute, like I said, just sprayer of a leak,
you're not going to be using the leak detector anyways if you've got a super sprayer of a leak.
so it's going to be pretty easy to find that leak, even in the cloud hunting mode. But if we're talking about finding the smaller leaks, well, the reality is I'd want to switch it to that pinpoint mode. And so when I hit the mode button on the Stratus, it'll go into this like LED bar indication, almost like an older style leak detector. and that actually shuts down the switching valve. So a lot of people, you hear that clicking on the Stratus. That's actually a switching valve that's kind of referencing the outside and the inside of the unit. When I go to that pinpoint mode, well, now I'm the most responsive and the most sensitive to actual leak rates, so to speak. And so that actually also has the automatic zero function, and it has the different sensitivity modes. So if high background, I keep it low. A lot of times you're good to just keep it in that super mode, which is the highest sensitivity. And that's what I really want to chase the pipes with. I want to go through the joints, and that's when I'm actually going to target exactly where those, and pinpoint exactly where those leaks are coming from. And this is really going to prevent me from missing leaks, because cloud hunting mode doesn't quite have the reaction time you need in order to alert you for those really small levels of refrigerant, or I would say small leak rates.
So in that high wind mode, because this is one of the things that I've had a lot of questions on, especially with the Stratus, like in that high wind or in an outdoor scenario where there's potential for air movement and things like that, especially, but even in an indoor where you're going to get air movement potentially, what mode should I be in for that?
Again, it's a tough one, because it really just depends on the environment. But if I'm not getting any background, right, and if I'm in cloud hunting mode and I'm kind of downstream of this system, it's probably a better idea to get it back into that pinpoint mode, because again, that's the most sensitive. I've got the best shot of it quickly alerting you. I'm not really using a reference. It's an absolute change in what's happening in that sensor, and it's going to just alert you that the refrigerant is there, or I found the leak. And so keeping it in that pinpoint mode is going to be important. I will say we are coming out with the Pro kit, which is an accessory kit for the Stratus that actually has brushes that you screw into the tip of the Stratus, or D-TEK 3 or D-TEK Pro, and that'll encapsulate the entire pipe. So that way, if it's windy, it'll actually block that wind for you, and you can scan the pipes that way.
Cool.
We also, in that kit, it's gonna have a needle probe as well. So if let's say you have insulation of some sort, rather than cutting that insulation down, you could just poke through that insulation with a needle probe, and then kind of use your measurements there. It's okay to keep it in ppm mode, because there's going to be a buildup of concentration behind there, so you can kind of work your way down a pipe to see, ooh, this is the highest concentration here, and let me go ahead and pull this section of insulation back, make my repair, or switch to pinpoint, and I'll be good there. So
Figure out where it's at with that pinpoint mode. Okay.
Yep.
Yeah, well, that's really good information. So in the cloud hunting mode, you said it's kind of comparing, it's periodically pulling a sample from next to the handle versus pulling it through the tip, and it kind of compares those two then?
In cloud hunting mode, yeah. So
Yeah.
it'll use the internal cavity of the sensor, or of the leak detector, sorry, and kind of makes its reference that way through a series of firmware calculations, and and what our geniuses at Stratus, they'll tell you more so, how that works through their firmware, but really that's the magic there and how that works. But again, it takes a little bit of time for that to actually, make that calculation and show you that ppm.
Yeah. So when we're talking about pinpoint mode, you said that's got the auto zero feature in it. How often does that re-zero itself?
It's within a matter of seconds.
Okay.
So you'll see it fall back down. So as soon as it goes up, it'll come back down, and then it'll go up, and it'll come back down. So as it gets to that next highest concentration, it'll spike, and then it'll just reset itself.
So does it reset itself like only when it hits maximum, or is it, halfway up, it's going to reset itself back to zero?
I think my headset just cut out on me a little bit. Could you just restate that again?
Okay. So does it reset only when it hits maximum on the display, or will it reset at like 50% on the display?
It'll go so it'll spike where it levels out at is then it'll come back down.
Gotcha.
So yeah, it'll always zero out wherever it's at. It's not really looking for a specific concentration to zero out at. It's just, oop, it hit this level. It's hanging there for this amount of time. Bring it back to zero, and then look for the next higher concentration.
So is there a way to do that manually in there if people want to do that manually?
And that's just, yeah, absolutely. And so manual mode will give you the ability to manually reset that. When I am looking at things or systems, let's say just CO2 is really one that I've found it's really helped people out. And the reason being is because there's so much of a background, right? And you need to have that ultimate control of the leak detector itself to really get yourself close to that leak. If the cloud hunting mode is totally maxed out, and really once you start getting past the 10,000 ppm range, it's really tough to gauge that background, right? Because if I'm jumping from 20,000 to 30,000 back to 25,000, I mean, it gets a little hairy to see the little changes at that point. My scale is so large. Really, then I want to change into manual mode and start to control that background myself. I walk into a store, everybody's here, they're breathing, the background's 11,000 ppm. Let me just zero that out when I walk into the store, and now I can start to look for those higher concentrations.
Awesome. Great information on that. Anything else you want to cover on the Stratus?
I don't think so. I think that's really just getting people to understand there's more than one mode. That really does help most of our folks out there with our leak detector.
Yeah, for sure. And that pinpoint mode and understanding the difference between those two modes was an eye opener for me. So good stuff. And I think now we want to talk about the new product. It's the new stuff coming up here. You got a slide queued up on that?
Let me see if I can get
We'll keep everybody in suspense. Of course, you've talked about it. Kind of like mentioned that back there. I didn't know if anybody noticed.
So can you guys see my screen okay?
They will be shortly. Now they can.
All right. So and just kind of coming off of the Stratus, this is something that we're coming out with this summer. It will be available, but this is a kind of a hyper focus for anybody who's really doing a heavy amount of leak checking, and finds it difficult to really use all the modes in the Stratus. It actually this leak detector is almost like cheating in a sense. It'll show you 1/10 of a ppm, but it also has that 1 second reaction time. So it takes all of that guesswork or all that understanding that you really need to know with some of our other tools, or like I said, the Stratus, and it kind of puts it all into one mode. The other thing that with all of the change in regulations, this will data log for you. So you can actually create a formal report through our app that will show the customers how long you've leak checked, where you found the leaks. It'll show you can take pictures through the app of the actual leak point, add your notes to it. It really, it's been a game changer for again, people who are really invested in leak checking and where leaks are costing them a lot of money. This is a tool that's really helped reduce leak rates in a big way.
Yeah, I'm excited to see this one come on the market. And I see on there that you've also got a GPS location on there to confirm the location of the leak check, things like that, which is,
that one's going to be for just to confirm the location of the store. So, if I'm at the specific store, or wherever, right. If I want to just validate and just, again, creating more of a formal report. Sometimes the proof's in the pudding for some of our customers that we service, right? And giving them the most information we can helps them make some decisions or makes it a little easier for them. So again, just that formal report is really something that our customers have been asking for.
Well, and this is something that is changing in the industry as we get the ability to gather this data electronically. We've talked about this on the podcast some. Rachel was on there, talked about data integrity, and this is part of keeping data integrity, right? This means that the technician was actually at this location when they took the leak. They took the leak check at this time. They found the leak. It was X level. That's making sure that your data has integrity. It's not just writing it down on a piece of paper and driving out of the parking lot that, oh, I went in and did a leak check and everything's okay. Well, tech said he did a leak check. Somebody else comes in and finds a giant leak, or the store goes down because it's low on gas because there was a giant leak and they missed it. Well, now you've got that timestamp on there. You've got that GPS stamp saying, yes, I actually was here for X amount of time. I took these pictures. I did this note. Here's all the stuff that says I was actually here.
Yeah. And the other thing that I would say about this is in terms of sensitivity. I mean, this is the most sensitive leak detector that we have ever come out with. I mean, I'm not supposed to say this, but I'm going to. It's competing with some of our really high-end benchtop leak detectors in terms of what we're really doing. So, it's where this helps is, let's say we're checking discharge air in a case, right? And, I've a lot of the times as that gas comes back through the discharge air, by the time it's picked up from, and makes it past the evaporator, back up, and then comes down in front of at the air curtain, it's really diluted. So this giving you that 1/10 of a ppm has really shown us where any other leak detector just cannot pick that level up. This is really showing us, hey, there's a leak here. And then when I get down into that coil that I wouldn't have otherwise, all of a sudden now I'm seeing 60 ppm or something like that down in the coil. So the sensitivity, the airflow, and then the ability to data log is really making this something that our customers are happy with.
Yeah. I saw this down in Florida. You guys had it at AHR and at the HVACR training symposium earlier this year. And it looks like an impressive tool for the toolbox. It's going to have a little bit higher price point than like the Stratus or something like that, because there's a lot more to it. But I'm looking forward to seeing this. I think for the much more regulated industries, grocery stores, food warehouses, things like that, this is going to be a really great thing for those technicians to have out there. And I guess we'll see this probably late summer of 2025. Yeah.
Yep. That's about when we're targeting to have it ready, and I'm pretty confident we'll get it there. So
yeah, well, with the way the supply chain works, some days I don't want to make any promises right now. We'll say late summer.
yeah, I'm going to go with that too.
Fair enough. All right, Nick. Well, I think I've taken up enough of your time tonight. Anything else you want to tell everybody out there?
No, but we're always open to questions. We're active on social media, and we have obviously our helpline for anybody who needs to get help with any of the devices they've bought from us. Don't be afraid to reach out. And we appreciate the time here tonight.
Well, thank you very much for joining in, and thanks everybody for tuning in. We will catch you all on the next one. Have a good evening.
Bye.